Hello, thank you for watching the info session for our data science programs at the Global Innovation Exchange. Our three flagship programs, Python Foundations, Data Science Foundations, and General Applications of Neural Networks, were seeded from a sequence of courses at the University of Washington in the Chemical Engineering Department. Those were Chemi 545 and 546. Those programs were created through NSF investment of $3 million over 5 years and had hundreds of graduate students in various departments at the university. So we took these courses and diced them up for professional learners, added some industry case studies, and tailored the pedagogy for busy professionals. We'll share some of our philosophy around that in this info session. In this image, we have a picture of the Direct Capstone Showcase in 2019, pre-pandemic, so no masks. My name is Wesley Beckner. I received my undergrad degree at the University of Texas in Austin in chemical engineering, my PhD at the University of Washington in chemical engineering data science. About halfway through my PhD program, I began to absorb the common tools of data scientists. And after I defended, I joined a startup in Houston, Texas called MFG Analytic. I joined their team as their director of analytics, and we had clients such as Kraton, DuPont, KP Films, Berry Plastics. We were consulting for folks in the manufacturing industry, developing cloud-based tools for our clients. Generally, we have a lot of different topics that we touch on in the data science programs. Those involve exploratory data analysis, both supervised and unsupervised learning, and neural networks. We have two new courses that we're launching this spring, data dashboarding and Python DevOps. We'll do a little bit of dashboarding in the Data Science Foundations and the General Applications and Neural Networks courses. But we have a dedicated course module to dashboarding as well. This curriculum is designed for professionals. I'll go into the pedagogy in a moment. And our courses focus on practical application of these tools. So we introduce some of the fundamental concepts and go and discuss some of the underlying mathematics, but the focus is on application. And this is so that you can hit the ground running in your professional life with the tools that we cover. I want to motivate also why this is good for your companies or organizations. I really like this white paper that was delivered by an international group back in 2020. It's called Smart Manufacturing Accelerates Adoption Post-Pandemic 2020-2025. The number one thing that they found in this study was that for companies that are seeking to leverage, quote, AI, machine learning, data science, the first thing they need to do is invest in people and training. The second thing is to clearly define return on investment and cost effectiveness. And the third is to focus on the problem and use case. What I have displayed here on the right are two software as a service packages, one from General Electric and another from a company called Sight Machine. And what I'm articulating in these images is that in order to deliver true machine learning and data science solutions for a company, it takes an extraordinary amount of infrastructure. And what I've circled or boxed here in gold is the component of this pipeline that we'll be focusing on in these courses, and that is the actual analysis. And so my point here is before your company goes and spends all of this money on these multi-million-dollar software packages and infrastructure developments, they need to find out if in fact the current state of the data that they are generating is usable for the projects that they envision, right? And so by sending people through these courses, they can begin to answer that question. A little bit about our pedagogy. I mentioned this earlier. So we deviate from just traditional lecture style. All of the notebooks that, or all of the quote lectures I give are in notebook format, right? So if you're somewhat familiar with the data science ecosystem, a lot of the work that we do is in Jupyter notebooks. And so our lessons are delivered through Jupyter notebooks. These are also open source and free for you to peruse online. I give demonstrations during our quote lecture time. We also have solo coding breakouts where we solve problems. At the end of every lecture, there's an associated lab notebook for students to go and apply what we have discussed and gone over that day. While we're in session together, we also orchestrate paired programming. If you're not familiar with paired programming, this is where the person who is doing the coding is at the keyboard, but they're not doing the critical thinking. They have a partner who is telling them or coordinating with them what should be actually typed and delivered onto the keyboard and into the program. So it sort of hijacks some of our social mental states to better integrate and settle into the concepts that we're learning, because we are social creatures. That's the broad overview, and with the remaining time, I just wanted to do a bit of a deep dive into some of the case studies that we cover in the courses. I mentioned that we are oriented around practical application, and so this is meant to articulate and share some of that. In the following case studies, I'm going to look at them through this dichotomy. We'll be discussing problems either at the business or the operator level of a factory that seeks to be data-driven. Business level questions might be things like consolidating products across different sites, looking at the velocity or the rate at which a certain product can deliver a margin. So this has to do with the cost of developing the unit product, the rate with which we can produce the unit product. We'll also look at the performance of assets across the entire business. Now, to juxtapose this, at the operator level, we're going to be looking at things like predictive maintenance around specific pieces of equipment, detecting defects in our products, and then doing cycle time analysis. So this is looking at an individual unit and looking at the products that are made across this unit and assessing whether we are delivering some things faster or slower than others according to different variables that describe those products. The second sort of lens we'll be looking at these case studies through is modeling either people in our company, modeling processes, or modeling individual pieces of equipment. And this is sort of the way you can think about data science or machine learning in general, is making these sorts of models of different things in our business. And those models can consist of simple regressions, trees, ensemble methods like random forests or XGBoost. They might be analogical learners like support vector machines, or they might be deep learning methods, aka neural networks. Okay, first case study. The business problem is this company makes many products with both discrete and continuous descriptive variables. So an example of a discrete variable might be it's vanilla cake or chocolate cake that they're making. A continuous variable might be the density of the cake substance itself. And what we can do here is we can draw distributions around the margin of either vanilla or chocolate cake. And in these pictures here, I've done such and drawn a black dotted line at the mean, and we can see that the mean margin of vanilla is much higher than the mean margin of chocolate, and we can conclude that vanilla indeed is a higher margin product. Now, this becomes convoluted when many different variables are changing at the same time. And to make matters worse, we may have very small sample sizes. So when we go to do this analysis, we need to consider, do we have enough samples of a given combination of components to make a significant determination of any individual variable on profit margin? And so this is an example of something that we go over in our Data Science Foundations course, right? So before we get to this case study, we will have developed a foundation in Python and feel comfortable with the Python programming language, and then we can go to discuss things like this. So we will delineate between many changing features to assess the statistical significance of any single one. Some of the sister learning concepts in this would be median tests, outlier removal, performing kernel density estimates, creating rank order plots and sunburst plots. Some of those I've shown here on the right. And this is an example of a business level problem that is focused on modeling a process. All right, so the business solution here, thinking back to that study I mentioned at the beginning of the session, we can now push on sales with statistical evidence to focus on specific products. And we can ensure clearly defined and calculated return on investment and overall cost of effectiveness. All right, second case study. I've got 3 of these, by the way. This is our second one. This has to do with predicting whether we have worn out our equipment and it needs to undergo some sort of maintenance. This is an operator level problem because we're modeling a specific piece of equipment. The business problem is, how can we leverage labeled data sets, that is observations of equipment failure in the past, to detect equipment failure in the future? In this process, a wax block that I've shown here over on the right undergoes a milling operation to produce some final figure, in this case, a little halo figurine. Some mill tools are worn, others are in good condition, and we have these labels. But alongside these labels, we also have, and this is key, we have the sensory data that is associated with the tool. So this is things like position, velocity, voltage, things that we are constantly have access to so that we can train our model to read in this data and predict whether the piece of equipment is indeed failing. Again, this is something that we also approach in the Data Science Foundations course after we've built our foundation in Python for this particular problem, and we'll apply simple regression methods to it. And before moving on to more sophisticated learning strategies like ensemble learning methods, in particular, when we go to assess the performance of our models, we'll find that random forests and XG boost or gradient boosting do very well. And as part of this case study, we'll also assess the significance of certain features. This is important for doing things like diagnostics, right? So once we have this model created, it could be enough to just have an answer, as in be able to accurately predict whether a piece of equipment is in good or poor condition. But as we will often find when we go to work with engineers in the factory or close to wherever the data is being produced, they'll want to know what actually is going on and which were the key variables for you to make that prediction. So that's something that we really focus on in this and other case studies. Some sister concepts that we also explore for this are inferential statistical analysis, along with descriptive statistical analysis like kurtosis, skew, and multi- and univariate analysis. To bring this back to the study I mentioned again at the beginning, the business solution is we compare the cost of a time-based maintenance schedule, right? So this is the traditional way we might perform maintenance on equipment in a factory setting. We compare this traditional method with a data-based one, the one that we have produced, and then decide whether to implement the strategy. Are we accurate enough in our prediction? What is the cost associated with creating the pipeline for this data? And again, this is an example of how we focus on the problem or the use case and develop a value proposition. Third and last case study, having to do with detecting defects in our product line. This is operations level again, and this time we're modeling people. We're attempting to replace the job associated with a person doing QA checks at the end of a production line. So the business problem, using people to manually inspect for defective products is expensive, it's time consuming, inconsistent, and can often lead to errors. What are the machine learning strategies for automating this process? In this case study, we'll have access to by data science standards, not an extremely large data set, but a large data set of images of motor impellers with and without casting defects. Okay, so this particular production line is creating motor impellers. And as part of our solution, we're going to discuss different strategies when our business situation varies, right? Okay, so for example, our strategy will be different if the cost of retaining false positives is high, right? So if we've said, hey, this motor impeller is bad when indeed it's good, if that's really expensive, we might want to minimize that situation. If the cost of sending false negatives to customers is high, i.e. where you say, hey, this motor impeller is good, let's send it to the customer, but in fact it's bad, we may have a different strategy for that. And so we'll discuss this in this particular case study. Some of the sister concepts that we will cover are image augmentation. So given a training data set, how do you do different kinds of permutations on the data to better leverage it for your the final training of your model? We'll discuss convolutional neural networks. In fact, that's going to be the best strategy for this sort of data. We'll also discuss ensemble learning methods with this sort of data. And we will, and this is key to that business situation I discussed earlier, different classification metrics for this type of problem, that is precision, recall, and F1. So if we're going to say that we don't want to send false negatives to the customers, we would want a high recall. If, on the other hand, we don't want to keep things that are good or label things defective that are in fact good, we may want high precision, right? So we'll discuss strategies for focusing on one or the other when we train and test a model. Bringing this back to the ISG study, the business solution is we compare the performance of a human quality assurance engineer to an AI one and decide whether to implement this strategy. And again, this is an example of focusing on the problem and the use case and developing a value proposition. That's all I have for you today. In conclusion, you can find final details and registration at gixnetwork.org/professional/data-science. You can email questions to proprograms@gix.edu. And our first Python Foundations course starts on January 24th in the new year. Hope to see you soon.